Hello and welcome to Legacy IAS Academy. Today we will be studying about one of the current affairs topic, that is Aditya L1. Okay. So let us first understand why are we reading about it, what is the news about. So recently ISRO, we know it has done a remarkable achievement by launching a satellite to go up to the south pole of the moon. Okay. So we have sent a lander cum rover module up to south pole of the moon. Okay. Apart from that, within 10 days of this time period, ISRO has recently made an announcement that we will be launching Aditya L1 mission on 2nd of September. Okay, so we will be studying about this mission of ISRO. Okay, that is Aditya L1. Okay, now let us compare it quickly with Chandrayaan 3, which has been launched to reach the south pole of the moon. This is going to study the sun. Okay. The distance that it will be covering will be almost 4 times more as compared to Chandrayaan 3, and the weight will be almost 2 times lighter as compared to Chandrayaan 3. Okay. So, what all part of sun will be studied by Aditya L1, that we need to understand here. First of all, we will be quickly going through about what is Aditya L1. Aditya L1, as we discussed, it is the solar mission. So in this, we are going to study the sun. Okay, it is the first Indian solar mission. So we will be placing our satellite at some position. This position is known as L1. Okay, now what is L1 and what is the halo orbit associated to L1? This we will be understanding. But let us first understand that this Aditya L1 will be placed at halo orbit of L1. Okay, and it is the first Indian solar mission launched using a polar satellite launch vehicle. So this is how the PSLV looks like. This is a polar satellite launch vehicle which will be launching the Aditya L1. Okay. Now, to understand this image, this satellite will be launched from Earth's surface and will take turns, turn by turn, and finally exit the Earth's gravitational area and reach up to L1. Okay, and from there L1 it will start moving around the halo orbit of L1. Now we will be studying what is L1 and the halo orbit of L1. But first let us understand the areas of study of Aditya L1. What Aditya L1 will be studying. Okay, so this is how the solar surface looks like. Okay, we will be studying solar corona. So corona refers to the outermost layer of the sun. This is the chromosphere. This is the corona. Okay, if we keep a ball object like this to cover this entire surface, okay, after this whatever rays are coming, this is all part of corona. So Aditya L1 will be studying corona plus chromosphere plus photosphere. Photosphere, that is the next layer to chromosphere, will also be studied. So it will be studying the corona, photosphere, chromosphere plus solar emissions, solar winds, flares and the coronal mass ejection. Okay, so solar winds and flares are something like this. So something will eject out a sudden bulge. See these are sunspots. Okay, from these sunspots something will bulge out, something will come out. Okay, and that is known as a solar flare. Okay, it will result into a wind. It will cause a kind of pushing. Okay, and it will push all the heat around it. This will be known as the solar wind. But this is something which is more important. This is the coronal mass ejection. Corona, as we studied, this is the part, the outermost layer. Okay, this is the corona. But coronal mass ejection basically means that some part of corona has been ejected, has been removed, has come out. Okay, this is the NASA generated image of one of the coronal mass ejection which has occurred. Okay, coronal mass ejection this is how it comes out. It's a major flare. Okay, we can call this as a solar flare or solar wind, in which a major wind has come out, major bulge has occurred. Okay, what is released in a coronal mass ejection? It is basically gas and magnetic field. But this is something which is affecting Earth. Okay, so under coronal mass ejection, there is ejection of bubbles and gases, and there is also ejection of plasma. Okay, release of plasma. Now, we know usually, now what is plasma? We usually know that there are 3 states of matter. One is solid, one is liquid, the third one is gas. But plasma is considered to be the 4th state. Okay, and this basically consists of charged ions. It is a group of mass of charged ion, and it is considered to be the fourth state of matter. And our entire universe is maximally consisting of plasma only. Okay, so such plasma are released from coronal mass ejection, and it affects the Earth's magnetosphere, and this is how it affects it. So for example, this is Earth. This is how Earth's magnetosphere is supposed to look like. Okay, but because of the coronal mass ejection, the magnetosphere of Earth is shifted. It bulges out from one end and it shrinks from the other end. Okay, so coronal mass ejection has affected Earth's magnetosphere, and thus consequently causes damage to electrical appliances. It has happened earlier, okay, because of the coronal mass ejection. So Aditya L1 will also be studying coronal mass ejection along with the photosphere, chromosphere, corona and all other parts. Okay. Now here we need to understand, you remember it will be placed at L1. Okay. So here we need to understand all those terms. Okay. So before we understand the Lagrange point, we first need to understand the centripetal force. So centripetal force can be something understood like this. Okay, you imagine a ball and you tie it to a string and try to revolve it around you. Okay, with full force, if you try to revolve it around you, it will try to come to the center of the string, the point wherein you are holding that string. Okay, it will try to come, this ball will try to come to this position. This is known as the centripetal force, and the force which is asking this ball to move out of the ring. Okay, as soon as you leave the string, it will move out. Okay, that force is known as the centrifugal force. Okay, so what is happening is when an object is revolving around Earth, okay, so there is a centripetal force which is calling this object to come to the center of the Earth. This is the centripetal force. Okay, there is one more force which is acting on the object, that is the gravitational pull of sun and gravitational pull of Earth. So all those points in space wherein the two gravitational pull are balanced, plus it is also balanced by the centripetal force. So ultimately on that object in space there is no force acting, neither centripetal force nor gravitational force, because the two gravitational forces are balancing the centripetal force. So if you place an object here, it will continue to remain in these positions. Okay, and there are 5 such positions between sun and Earth. There are 5 such positions. One is L1, second one is L2, third one is L3, this is L4, this is L5. Okay, now what we see here is the points, but in reality it is an orbit. It is a circular orbit. It's a 3-dimensional orbit. Okay, these orbits are actually known as the halo orbit. So Aditya L1 will be placed in the halo orbit of L1. So it is not exactly this point, it is actually this circle. That is why in this image it was showing that it is this orbit. This is L1 and it is this orbit in which Aditya L1 will be placed. Okay, so that was all majorly with respect to Aditya L1. One more thing is, there are too many payloads, 6 to 7 payloads which are carried by Aditya L1, and not all of them are important. There is only one payload which is important, and we will be discussing the technicalities, some technicalities associated to this payload. Name of this payload is Visible Emission Line Coronagraph. Okay, this is known as VELC, Visible Emission Line Coronagraph. Okay, under this, this payload is bound to study corona. Okay, because it is studying corona, so it is having a coronagraph. Because it is studying the spectrum of white light, the band of white light will be studied by this payload, so it is having a spectrograph. Okay, but it is also having a polarimetry module. Now what is a polarimetry module? See, light is basically a wave. Okay, so because it is a wave, it is bound to move in this direction, like up and down, up and down, up and down. Okay, but in reality what happens is it moves like this, sometimes up and down, sometimes left and right, then up and down, then 30° left and right, then 40° left and right, then 45° left and right. So there are a number of ways in which this wave keeps on turning. Okay, once we polarize the light, after polarization the light will be uniform. Okay, it will be uniform, and then it becomes very easy to study that surface. Okay, so for example, this is an image generated by a non-polarized light. Okay, this is the image generated after polarization of the light. So this is way clearer as compared to this one, right? We are introducing a polarimetry module. That is why this payload is very important, because this polarimetry module will remove the noise that is created by light and will generate one single light that we need to study. Okay, and that is why this payload becomes very important. Now, how will they do it? They will open the shutters for a very small time frame. That's just 5 milliseconds exposure to sunlight, and then close and then study that, or polarize that and study that. Okay. So these all will be carried by this payload, and that is why this payload is very important. This is developed by again an Indian institute itself, by the name Indian Institute of Astrophysics, which is located in Hoskote in Karnataka. So they have delivered this payload to ISRO, and ISRO is ready to launch. They have declared the launch date as 2nd of September. Okay. So with that, we come to the end of this topic. If you have any confusion, please do let us know. Thank you so much and all the very best.